All right, so in Module 16, we were looking at using inheritance in classes, and we came up with kind of a natural example of using a base class called shape. And we used inheritance to develop a circle and a rectangle, which borrowed some properties from the shape class. So the shape class defined a color and a Boolean property as to whether or not it should be filled in or outlined. And so those base properties, and then of course the circle and the rectangle having actual dimensions and perimeters and areas, sort of lends itself well to actually drawing them on the screen. And it turned out that the low level, the way to do your graphics all by yourself is probably well outside the scope of this class, but there's lots and lots of libraries and code that you can draw into your program that it can help you do this really easily. And so I use the Easy Graphics package, which is actually something specifically designed for the educational environment. It's not a full-fledged graphics package. It's certainly not going to help you with 3D graphics and that kind of stuff. But it's a really easy library of classes, Python classes and Python functions that let you build graphical windows and draw basic shapes to them. So they're perfect. It's a perfect library for us to actually take advantage of, the example, the analogy of shapes and circles and rectangles, and actually start drawing them to the screen. So for this example, I'm going to first off recognize that all shapes, if I'm going to actually draw them to the screen, all shapes are going to have a position. So I'm going to add a base property to the position, the shape class. It'll be a tuple for an XY position. And that will be, of course, inherited by circles and rectangles. And I'm going to implement a drawing function for both a circle and a rectangle to actually draw themselves to the screen in the color and the position and the dimensions and whether or not it's outlined, defined by that instance of the class. So one thing I assume before you watch this video that you've tried this program, and you have to actually look at the documentation for the Easy Graphics web package to be able to know how to use it. Most of it's fairly intuitive, but this is a really good use case to pay attention to, because you're going to be able, if you can develop the skills and the confidence actually to go and grab libraries that you can integrate into your program, you can start to program. The complexity of your programs can grow a lot faster, and you can start to do a lot of really nice things. But it takes some patience in terms of looking up and finding good libraries, finding the documentation, and realizing that although you might not know anything about the actual library that you're using, you can probably look at the source code and you can make some sense out of it. You can read the documentation. So I'm going to kind of talk through the Easy Graphics, just the part that we actually are using for this particular exercise. But again, you probably should have already read that before you're watching this video. Okay, so first off, let me collapse this. I got my in my Sublime editor, I have the directory structure, of course. And first thing I want to point out is that I have downloaded and I've saved the Easy Graphics Python file into the actual directory that I'm going to be programming in. So that's important because later you're going to see me import the Easy Graphics library in a second, and for that to work, that graphics library has to be there. So this is essentially a module, right? It works the same way, and it's a by libraries that you download standards, it's not that big of a package. It's not that big of a module, but it is quite a bit of code. I mean, you can see here it's 700 plus lines of code. A lot of this deals with the underlying windowing system. It's using TK to develop graphics library or graphics widgets. But if you scan through most of this code, aside from some of the odd naming conventions or something like that, it's pretty sensible, right? We've got classes for graphics window and classes and methods associated with all this stuff. So that should be downloaded in the same directory as the program you're working on. And at that point, I mean, there's lots of documentation for the Easy Graphics package. So that's probably the best way to learn how to use it as opposed to just staring at source code. Let's go over to the exercise code. Now, I didn't start from scratch here. What I did is I took the code that was developed in Module 16, and that was creating the basic shape class that has a color and a solid. It can turn itself into a string. The circle class extending shape, the rectangle class extending shape. And you'll notice that I'm giving default colors to all of these, and Easy Graphics package kind of understands these basic any of the colors in the the 8-bit color system. All right, so before I worry about adding anything to these classes, I need to verify that my graphics library actually works. I can get a window up and allow it to get started. So the first thing I'm going to do, and I can do this at the top, or I can do this, as long as I've done it before I start writing code for the graphics package, I'm going to import it. So again, since I already downloaded the Easy Graphics file, I can just say import Easy Graphics. And now I'm just going to bring up a window. And again, from consulting the documentation, I saw that it's pretty easy to start a window. There's a graphics window class, and I am, if we saw it like this, we know that if we're instantiating a class, we just use the class name, right? And that calls the init function. Let me just get rid of this. And in fact, if we go over here, we can see the graphics window class right here, and it's got an init function, and it's doing some things with some global variables and setting up a windowing system. But we're just calling it, and the only reason we've got Easy Graphics prepending it is because it's coming from our library. But this is really just calling an initializer and creating an instance of a graphics window. At this point, we've got some methods that we can call. I'm going to call set title, CMPS 130, P25, and that'll give me the title bar. That'll set the text of the title bar of the window. I can then create a canvas, which is it's probably best thought of as the area where we can actually paint on. We can draw things on a canvas. A window itself, if we think about like the editor right here, the window itself is really like the close and the maximize and the minimize windows, the menu, but the interior here would be considered like the canvas, the part that this program can draw to. And of course it's drawing text, right? And it's doing a lot of work to make that really nice. But that's sort of the available spot for the programmer to draw stuff, where this is really just part of the operating system. All right, that's the title bar. I don't really have much to do here yet. So eventually draw shapes. But to get everything started, I call win_wait. And what win_wait does is it just says to the window, keep drawing until the user closes it. Right? And so that's from straight out of the Easy Graphics documentation. We can just get a window up and running. Let's see if we can run that. Okay, and there we go. All right, so we've got a window. We've got a title bar. It doesn't have a menu. It doesn't have a maximize, just a close and a minimize. It's not drawing anything right now. That's okay. It's not a problem. We'll eventually start to draw things. Okay, so when we close it, the program stops. All right, so just to kind of make sure we understand this a little bit, I can draw rectangles, I can draw ovals, I can draw lots of different shapes, and certainly we're going to draw a rectangle, we're going to draw a circle or an oval eventually, but let's just make sure that we know what to expect when we start to see it. So the draw rectangle function, for instance, of the canvas takes a XY start position. It's the top left-hand corner. So let's just say 5, 5. And a height and width. So let's say 20 or maybe 200 and 100. Okay. So if we run that program now, we see it, and we see that by default it shows up with a black outline and it's hollow. So we can change that, and I think experimenting with that before we actually get right into the inheritance and all that kind of stuff is kind of useful. So how do we change that? Well, again, you want to actually go into the documentation and look at this, but the canvas, you think about it as having a state, almost like a brush, a paintbrush has a state. And everything that you draw with it, everything that you try to draw, so drawing a rectangle, for instance, uses whatever the current state of the drawing system is. And one of the states is what color you're going to draw with. And the other, and there's two sort of brushes that you can think of when you draw. There's the brush that you're using for the outline, and there's the brush you're using for the interior part of it, the fill. And that'll actually be very helpful for us when we start talking about the solid and outlined. So I can do canvas dot set outline, and I can pass in a color. Oops, that should be an uppercase. I can pass in red, for instance. And when I run that now, the outline will be in red. And again, there's other ways of specifying colors. Like if we want to do an RGB, red, green, blue hexadecimal value, that'll work as well. But for our purposes right now, we've been using colored words for colors. Obviously, if you type in some ridiculous name for a color, it's not really going to work. You see it crashes. It doesn't understand what XYZ is as a color. But as long as you use the basic kind of well-defined colors, we're okay. And we can also set the fill. So canvas dot set fill, let's say blue. And now you got to look kind of closely, but there's a red outline here, and there's a blue fill. Now the Easy Graphics package allows you to define the width of the outline and a number of other properties, but that's actually pretty sufficient for us, because if we want to draw a solid rectangle or a solid oval eventually, if we want it to be solid, we'll set the outline and the fill to be the same color, the color of the shape. If we want it to just be outlined, we'll set the fill back to nothing or transparent. And the way we do that is just by calling set fill with nothing. Right, and that just makes it transparent. So it's not that it's white, it's just that it's not drawn. Set fill with nothing will set it back to being not drawn. And I can draw multiple things, right? So if we say this is in blue, then we can do canvas dot set fill transparent and do canvas dot draw, let's say an oval, which takes a start and an end point again. Let's say 200, and let's make it 100 by 100. All right, and now we see the outlined circle. All right, so that's a quick little overview of how we would actually do the drawing. But now we don't want to do drawing outside of the class. I actually want to implement logic into my classes so that they can actually draw themselves. They know how to draw themselves when we call them. And the first thing they'll need to know, and if we look at this, the first two parameters of any time we try to draw something is the position on the screen. And so that's something that they'll need to know when we create them. So I'm going to go up to the shape class, and I'm going to say, well, look, every single shape that we use will have a position. And I'm going to set a default position of 10 by 10, or x of 10 and y of 10. So I won't start it at 0, 0. And I'm going to store that in the class. Now, why is that being put into the shape? It's because whether you're a circle or you're a rectangle, you still have a position, right? And so that's a common property. It makes sense to put that on the base class. Let's go to circle, and let's look at let's actually think about having a function that is capable of drawing to canvas. So we'll say draw. Now any member method contains self, but if we look down at this code, what's actually doing the drawing, right? Well, it's this canvas, right? And if I took this is sort of the oval code, right? If I just took this over here and put it over inside this method, hopefully you recognize that well, that's not going to work, right? Because this function doesn't know canvas. It doesn't have a local variable declared as canvas. So that's definitely no good. We need to fix that. And the way we're going to fix that is by passing canvas in as a parameter. So we've done set fill. Let's do set outline as well. Now this is ignoring what the actual properties should be, and we'll get to that in a second. But there's our draw for a circle. Right? Now we're not respecting position just yet, and we're not respecting the size just yet. But let's see how we would make this all work. Well, we can call. Let's get rid of our sample drawing code here. We can call circle equals circle radius equals 80 or 90. The color, let's make it green. And the position 50, 100. Okay, so sort of an arbitrary spot. And now I can say circle.draw canvas. Oops. Need my semicolon. Looks like I'm missing some more too. Let's see here. Oops. Position equals a tuple. Okay, so I got, it looks like we've got an exception. Init got an unexpected keyword argument, and that's because when I called the init function of circle, I messed with this. I changed shape, but I didn't actually change circle. So let's add that position, and that's gonna we can decide to have a new default for that if we want. We can just keep it the same. That's fine too. And we need to pass that in. So remember, when the derived class gets initialized, we're just going to pass these parameters back in to the shapes in its init function. Okay, so now we got things moving, and of course it's not really at position 1010, and it's not at position 5100 either. It is at position 200, 200. And so that's because we're not really paying attention to any of the properties of the actual circle. And in fact, if we draw two circles, say circle 2, and we draw that somewhere else with a different size, let's make it blue. We'll start it at, let's say 10 and 20. Each one of those circles has its own initializer. They're both being drawn, but you're seeing it at the same exact spot because we're not using the internal properties of the circle. So what I'm going to do up here is I'm not going to set the outline to red. I'm going to instead set the outline to self.color. All right, so first off, the color associated with the actual shape will be used. For set fill, I really have two choices. If this shape is a solid, then I want to set the fill to be the color. Right? So if self.solid, then let's just copy this. I'm going to set that to self.color as well. Otherwise, I'm going to set it to be transparent. Now for the actual circle, the position is really just part of the self object. So self.position, and x will be the first attribute. Self.position 1. And now we'll just take radius. That'll be the width, the height and width of the oval itself. So self.radius, self.radius. Okay, and now I do see two real circles, right? Both of these circles have their own properties. They're being respected. They're being drawn. I want to generalize this a little bit so I don't have to call draw. I want to add actually a lot of different of objects. We'll call them things. I'm going to make this a little bit more streamlined. That'll help us as we start to add more. I'm going to create a new list of things. I could have called them shapes, I guess. And I'm going to just add these new references to them. And this is actually like kind of a precursor to what a graphics programmer would call a scene graph, where we've got a list of objects that have been created and we just draw them by calling the same function over and over again. So here I'm saying, okay, well, I'm going to add two different things to my things list, and at the end I'm just going to say for thing in things, thing.draw canvas. All right, so a little streamlined, and then as we start to add things to this, we can continue. We don't really need to change the code as much. So we can add yet another circle. If we want to start that at 100 and 200, make this, let's say cyan. Oops, cyan should work. And also let's make this one not solid. So we had the keyword solid, we'll make that false. Okay, it doesn't really show up very well, but there's that cyan one. Maybe we should change that to red probably. All right, so now let's go ahead and add the same functionality to the rectangle class. So the rectangle class is going to get a new parameter into its initializer. It's going to pass that parameter to the base. And it's going to have a draw. And if I look at this draw function, I can copy it, and it's largely the same, right? I'm still going to have the same exact logic here, but I'm going to change this to be draw rectangle. And I'm going to use width and height. I'm going to get back to that in a second. Let's see if it works. Let's create a rectangle. We'll set width to be 25, height to be 45, color, let's say blue, and let's make this true. We don't want it to be at the same exact position, so let's make 150, and let's make this 75. Okay, so let's see what happens. Okay, so there we've got our blue rectangle with a width of 25 and a height of 45. So everything that's working pretty nicely. Now this logic up here is exactly the same as the logic over here. And inheritance is not only for saving yourself variable declarations, it's also for saving yourself logic. And so when we have common logic, right, every shape is going to do the same exact thing. And when we have common logic, we can try to put that in the parent class. So let's see how we do that. The set outline, set fill, really what you're doing is you're preparing the canvas to be drawn. You're setting the state of the canvas. So I'm going to take this code. I'm going to move it into the base class, which, by the way, doesn't know how to draw itself. It can't call draw oval or draw rectangle. We don't want it to do that, but it can have some additional logic. So let's say prepare canvas self, and we'll also pass in that canvas that we've got. So again, color, solid, that's all part of the base class. There's no problem with us actually accessing that. And now in circle, I'm just going to call that base class function. And I'll do the same exact thing in rectangle. That's a much nicer solution because now if we add any other kind of state, maybe line width, for instance, if we added that to the base class, none of the other children classes, the circle or radius, would need to really care about that, or really need to worry about it, because they would all just be calling into the base class. So again, as we run this again, we'll see the same results. We should. Prepare canvas. I need to write self. Let's run that again. If we run that again, now we've got the same exact display. And we can keep adding as many things as we want to this. Our things list can grow. So let's say 100, 50, green, I'll put that at 250. So we've got the, and it looks like we've got the makings of a scene graph here. I want to figure out why we just lost actually that last. Looks like we lost the last rectangle. Let's see what that's all about. Let's see, problem with that. So, oh well, yeah, they're in the same position, so that's obviously not going to be good. Let's change this to be 200 and move this over to be 75, for instance. Okay, and now we've got everything. It looks like I blocked my other circle too. So as we start to draw, one of the things that Easy Graphics does is it's just, if you draw a rectangle after you draw a circle and it's on the same spot, it'll just draw right over it. But that's pretty standard procedure. Okay, so we've gotten, we've been able to take advantage and sort of exploit inheritance to share some logic. This is a really good example of being able to call a base method, not just use base properties, but use a base method, sharing some logic and working with a graphics library that, just through documentation, we can get a nice, pretty nice looking little app together pretty quickly.